Okay, hello. So first of all, my question is, how many non-Polish speakers we have on a audience? Okay, two. So we will do it basically in English then, to give you opportunity to understand it. Okay, my name is Paweł Janusz, and my presentation is about thinking and developing in the cloud, mostly in AWS with a bit of serverless architecture. So quick words and heads up about me. I'm a happy father of 3 and a husband. I'm located in Lublin. I'm taking part in a Jugmaster contest. So I invite you to vote not only on me, but also the other guys using the Inventory application. I'm mostly JVM-oriented person, about 10 years in JVM. It was a funny situation about it because on my college I said that I will never use the Java because of one guy. And after 2 years, and my wife is laughing about me about this, I had to move to JVM, and then I got started to investing my time on that, starting learning more and more, till even to be an architect. I have an experience in almost all roles in company, excluding CEO. So if any of your company is looking for CEO, I'm raising my hand, and you can hire me. I will be happy to start it. My experience is, overall experience is more than 12 years. I'm always interested in new design patterns, new designs, new architecture types, and JVM trends. And currently I'm on Velo worker as a solution delivery manager. If you want to tweet with me, my Twitter is at Chujnik81. So you're welcome. Okay, let's start with agenda. We'll say a couple of words about cloud architecture. Then we'll review AWS basic possibilities. And then we will look on some serverless services that AWS is offering. At the end, we'll try to, because on the previous lecture we had some issues with this kind of stuff. I hope that it will work, and I will be ready to roast for you a small service. So let's start with cloud architecture. Once day I sat with my daughter, and I said to her that, please give me 5 minutes, I need to do something in the cloud. She asked me, Daddy, what are you doing? You're just sitting on your chair, not flying in a plane. So the cloud architecture is something a bit different, but as on this image you can see, the cloud is everywhere. And this is how we usually understand it. It's not right, but we will go to it. We'll ask Wikipedia, what's cloud computing, cloud architecture? It's type of, this is important, internet-based computing that provides a shared computer processing resources and data to the computers and other devices on demand. This is important that it's accessible through internet, and those resources we are buying, we are owning, let's say owning, are shared. They are not our own. We are sharing those stuff with the other customers. And we have a couple of architecture types. If we look on the architecture of clouds, it's infrastructure as service, IaaS, platform as a service, PaaS, function as a service, FaaS, or backend as a service, BaaS. Lots of A's in here. Software as a service. And if we think about possibilities, what gives us each of them, we will find out that we are already sometimes using those stuff. For example, the infrastructure as a service is just buying the virtual machines in the cloud. So we are buying, let's say, time of processor memory and the storage in between a typical virtual machine. Platform as a service, it will be more like tools. Heroku is a good example of it, where we have a bunch of services and we can use them. Function as a service, this is, let's say, very common usage of a serverless architecture, which is creating a micro, or we even can say nano services that provides business functionalities. And this is what we are today, I hope, trying to do. And last one is a software as a service, which could be, for example, this is a good example of it, where we have a software installed in a cloud and we are just using this software. What to choose? It depends on our needs. As usual, we can choose everything and nothing if we need it. But what's important in that? You always have to keep in mind that if you're using some kind of platform, that means for you that you're very strictly connected with your vendor, usually. At least this is for tools like AWS Lambda. Okay, let's go forward. What's AWS? Let's try to figure out. It's Association of Women Surgeons? I think not. We are not surgeons in here. Aircraft warning service. Service means more familiar, but I don't think so. Architectural, very, very simple. That's kind of helping, but unfortunately, that's not that. AWS is an Amazon Web Services, which provides us a couple of tools which we can use. And we will go now and try to look into them and try to figure out what we can do. One more important topic about cloud computing is collocations. What's collocation? Basically, it's a way that we can create the machines and run our piece of software in a different zones, in a different locations, physical locations. This is important if we are creating, let's say, overseas software. We have some customers in Europe, and we have some customers, for example, in the US. If we want to provide them a very good timing of the software, so less access time, things like that, latency, small latency, we should think about having 2 or more collocations. How to achieve this if we have our own infrastructure? It's very hard for us. How to do it in a cloud, in the AWS? It's very simple. We're just clicking and creating machines in the different locations. Should I care? That's the answer for you. You have to think about it whenever you are in need or not. I think that if we are creating an internal tool, we can forget about it. But if we are creating a tool which is for customers, some e-commerce or something like that, that's very important to touch that subject and even think of maybe it's for us cheaper to pay for monthly bill from AWS rather than have own infrastructure. What you can see in here is current AWS collocations, which are the split is between regions and zones. Regions is, let's say, a conglomerate of couple of data centers, and availability zones are the real data centers they own. So for now, we have 16 regions, which are marked as orange, let's say, with numbers. Believe me, they are in here. You can find this image in the AWS webpage. And the green ones is the one we are expecting to have. We have, in those 16 regions, 44 availability zones. That means that even in single location, for example, in Europe, in Ireland, in here, we have 3 different availability zones. Oh, sorry. There is a plan for a couple more, 5 more, I believe. And this is a screenshot of services. You barely can see it, right? Great. I will try to show it on a Chrome. Maybe it will be easier. It's an old one, but what I want to show you in here, that the possibilities we have in here, there are really bunch of them. They are related to IIS, so computing, serverless like AWS Lambda, networking and monitoring like CloudFront, some kind of storage tools, database tools, migration tools, and so on and so on and so on. There are a bunch of them. Couple of them I will mention today, and I will try to show you just 2 or 3 of them. So what to choose? If we are thinking in serverless architecture, who is familiar with serverless? Guys, hands, just okay. So we try to do it more simply. Serverless architecture is something that allows us to run our code with, let's say, without thinking about the architecture. So we have services, and we just use them. Implement stuff, just use them. Don't think where to run. Don't think about servers we need to run. Don't think about memory, storage, and so on and so on. So this is the base of serverless. And we have a couple of tools in AWS which are related to it. SQS, messaging service, AWS Lambda, which is kind of container-based small nano services. Notifications with SNS, and API gateway we'll talk about. If we want to buy just a simple machine instances, it's also possible through AWS. There are 2 typical services for this purpose: EC2, Elastic Cloud Compute, and Elastic Cloud Compute for Container Service, which allows us to run, for example, Docker images inside the AWS infrastructure. We have also Elastic Load Balancer, which can balance the load of our application in between our servers, and build private cloud, virtual private cloud, which allows us to organize our infrastructure, let's say. Other services, for example, database service, where we have, there are not all of them, just a couple of them. Aurora, which is MySQL implementation of Aurora is an database AWS implementation of MySQL. They say it's quicker, better, nicer. We did some tests. They look promising, but let's say not so much as typical MySQL. You can buy an Oracle instances. You don't have to even have a license. Of course, you have to pay it for AWS. MS SQL services and NoSQL solution from AWS, which is a column-based database called DynamoDB. If we want to buy some storage for our instances, or even keeping our files or making some backups, we will use, for example, Elastic Block Store, which is a service that provides us just the storage. We can buy storage on magnetic devices, hard drives, SSD, and even if we have a bigger and bigger instances, we can even order IOPS, depending on how quick and how much money we want to spend on it. Some of EC2 instances have their own storage attached, which is also helpful. We have a simple storage service, details later, and Glacier, just a second, and we will look on that. So, more and more AWS device farm. How many mobile devices developers we have in here? Just a few, but okay. It allows us to run our tests in an AWS infrastructure on the devices. So we can borrow those devices, lots of devices, to run those tests. Glacier, which is a backup storage. It's a silly thing how they charge you for this particular service, because you're not charged for the storage you are using and not for the stuff you are putting there. You're just paying if you want to download the stuff. Of course, the time of providing those data is not so amazing because it's backup oriented. Another service is Elastic MapReduce, EMR. It's good for any big data guys. Very easily we can create a cluster with Hadoop, Spark, HBase, or any modern tool we can think of. And a nice tool for EC2, which is auto-scaling, which allows us to buy and configure our machines earlier, then turn off some of them, and based on load of the system, the AWS will scale up or scale down amount of machines we want to run. So this is pretty nice. And we are, of course, charged only for those which are already running, those we have configured. And, of course, the very important thing for any operation guys, which is CloudWatch. It's a very big tool for monitoring stuff, not only just looking on the graphs, but logging as well. This is just a built-in and supports services as it looks like. Okay. And as well, there are some couple of developer tools. I heard about one service, one company only that uses this. So I know that they have some kind of CI or any tools like that, but not in details, to be honest. And of course, security. AWS provides us IAM, which allows us to implement the security and to have a single place of security implementation for our services, access management, and so on. So as you can see, there are just a couple of them, not all, of course. And even though I spoke a long time about it. Let's start with serverless. The first service we look into is API Gateway, which is a single point of input for our REST APIs. It's, of course, API oriented. This is obvious. Single point of API configuration. Later on, I will try to show you how to do it on a short live coding. So you will see what I meant by this. It's very scalable using CloudFront. And as a serverless service, we don't care about how many machines we need, how many memory we need. We just buy the service. And of course, it allows us to use AWS Auth services to enable security. Operational, from an operational point of view, the monitoring is enabled through CloudFront. Yeah, and that's basically all about API Gateway. The next thing we will also touch today with a small code is AWS Lambda, which is function as a service. We write only logic in here. I will show you just a simple stuff, but yeah, you will see how it's simple to write down such service and how easy it is to create a test against it, even without infrastructure. It's optimized for a runtime. I will show you how you can configure it. The payment model of this service is amount of memory your service needs and how long the timeout should last. So if we are creating a very small bunch of functions, which is a good idea for this particular stuff, you can see how easy it is to implement it. Pay as you use it. So you can create a code, you can create everything, deploy it, and you spend no money on that. You spend money only in a moment when your customer or testers or your team is using your API. So this kind of tool is something you should think of more about customer stuff rather than the internal tools. Or even you have a good relationship with the AWS and they don't charge you so much. We are creating a code, but how to invoke it? We can invoke it through a couple of different triggers. One of them is mentioned as API gateway, but there are a bunch of them different. For example, S3, I will talk more about the service in a moment. If we put a file to S3 or download it, the AWS Lambda can run and process, for example, this file. Action on database DynamoDB. Also, if we put a record or remove it or update it, we can act on that. We can easily activate Lambda through SQS, so a simple queue. And there are also streams which can provide us data. DynamoDB, also serverless product from AWS. Column-based no SQL database. That means that we are defining the columns and we know how the structure looks like. There is also possibility to put a whole JSON, for example, into a single column. So we can try to build something like a Mongo documents, let's say. It's 100% cloud and serverless, so we are not buying servers. We are just buying storage and amounts of usage of that and the throughput. So if we want us to have lots of data be downloaded or inserted or updated or deleted, the throughput has a really big impact on that. Seamless scaling, that means that we are not even seeing how the application is, how the database is scaling, because this is totally out of us. We don't have, we care only about data and the software which is using those data structures, nothing more. Replicated into multi-regionality, that means that our data are safe. If we think about cloud, what means that our data are safe? That's a really tough subject. We can talk about it for another presentation, I think, the security of the cloud data. What's the issue in here? There are always some issues in services. The issue is that there are not so many stuff for making queries. We can just create a simple queries, but if we want to have more advanced queries, we need to use Redshift or MapReduce integration, which is something which what AWS is allowing. S3 storage, mentioned a couple of times. It's a simple storage service similar to Dropbox and G Drive. It's backed, so our files are backed. If anything bad happens, they can create, they restore the backup. Does any of you remember a couple of months ago there was an issue with, I think, some services. I don't remember, it was GitHub or Slack. And what was figured out that the guys from AWS, the one guy, restarted the S3 server in one zone and forget to make it up just by one stuff, and half of America had issues with downloading those data. It's organized in buckets. In bucket we can store a file, files, different ones, and it's widely used. I think that you know most of those logos in here. So Dropbox, Spotify, Netflix is I think best examples that they are using this kind of storage. Simple queue service. It's a asynchronous communication service. It can be work in two different ways as a standard queue. So the delivery will be done at least once. At least once means that it can be one or more. And if we have FIFO queues where we have exactly one invocation, so process. It's a typical messaging service, very easy to implement on our side, very easy to put those data in there. And it's like JMS, like API. Unfortunately, we don't have enough time to show you how to work with that. But believe me, this presentation could be even 3 hours long, and we have a bigger example for that kind of service. Simple notification service is something I think that may be also usable as a serverless architecture. Is a publisher subscriber messaging implementation. One of the services provides push mobile notifications. If anyone knows FCM or older GCM, Google Cloud Messaging or Firebase Cloud Messaging, this is something similar, that notifications can be pushed to mobile devices, as well as SMS notifications. They're easy, of course, to integrate with queries, queue service, and lambdas. Okay, so let's make a quick example how our service will look like. We have a user, let's say this is a user. We will use API gateway, a REST service, and then we will run a simple AWS Lambda. We will look how it works. What kind of technologies we are using? Of course, AWS, API gateway, and AWS Lambda. And we are on JDD, so we will use Java, but really limited part. Okay, let's try. We'll see whenever it's going to be green or not this time. Yeah. First of all, we have simple Java applications. Oh, you don't see anything. We'll try to make it like this. A bit better. Okay, so we'll need 2 dependencies. First of all is because I'm lazy, it will be Lombok. Yeah. And the second one will be AWS Lambda core. This is basically what we need. Yeah, and now we need 2 classes. One of them will be request. And yeah, let's make it as data. No args. All args. I'm not pretty sure if it's required, but let's see. We create 2 fields. Simple one. And the second field. And another Java class, which is response. As you can imagine. Data, builder. I think it's enough. Sorry, my fault. Better? Great. It's easy class, just strings. Let's say output. Okay. Now we need another class, because what we did right now is just DTOs. Now let's roast some real hard to implement service. It needs to implement request handler from AWS Lambda. You can see no. Okay. Request handler from Lambda service. com AWS blah 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 runtime request handler. And what we need right now is just an implement. Where is it? Implement. Generate. Yeah. Just a simple method. Ooh, bad one. I do it not wisely. I can use some templates where we have request in and response out, and we'll implement the method. As you can imagine, what we will do right now is just implement an output. Request response out. We use our lazy builder. We create an output. We use request in field 1 plus request in field 2. Yeah, seems simple, right? Okay, so what we will do right now is just compile it and move to AWS console. Okay. First of all, we need to find the service, so we have AWS Lambda in here. Yeah. We're creating a function. Easy, right? Just clicking. We are using from scratch. We'll name it as JDD function. We will use existing role. This is better. Not not from my perspective. We create a function and then we configure it. As you can see, there are a bunch of different runtimes we can write those services. We are on JDD, so we use Java, but we can use Python, Node.js, and C# as well. We'll upload our example. Yeah, and JDD Lambda. You can see a small jar in here. And what we need to do is to put a handler. For Java, it's a total name of a package, package name with class name, because we have this on our default, and the name of the Lambda is service implementation. As you can see, no package, just name of a service we are putting in here. Yeah. This is something interesting. We can settle up how much memory we want to allocate for the service and how quick the timeout should reach. The memory is important if we have functions that allow that needs more memory. Of course, more memory means that money are rolling more faster on AWS side. Okay. That will be fair enough. We can settle some environment variables, but not important right now. Okay. So let's save it and test it. Yeah, I have some old test case for it. Let's see how it executes. Seems it's working. Let's look on how it was done. The test case is like that. I'm sending just a simple JSON file with the field name 1, field name 2. It's exactly the same as we had for our request class. You remember that. So if we change value 3 to value 1, we can save it and we can test it. The response is different. It acts exactly as the AWS Lambda. Okay, seems to be fine enough. I think not. We need to expose the API as well. So we will use a different service, which is API gateway. It will be more clicking in here. Yeah, okay, I like you as well. API, how can we call the API? No, API, it's fine enough. The description will be JDD. Okay. So we have API. Now we need to create a method. Let's post it. Okay. How the configuration looks like. We choose AWS Lambda, select the region. I have a default US region set up. It's US East 1. And this is something they need to work on. I don't have any lookup on that. To look on my AWS Lambda, I need to start writing, and then the lookup appears. I don't think it's user-friendly. Okay, I like you as well. Save it. Good. We have API. But if we have an application, at the end, what we are doing with that on a production? What we are doing? Debug. No, debug if something goes wrong. Yeah, I understand your approach. Okay, no worries. Ooh. Okay, it's easier than that. It's deploying the application. We'll create a new deployment stage, which is the best tests are on production. Yeah. So we are on it. Look, we have an URL for it. I will just copy it. I like my Postman tool. Paste it. In body, we have field 1, field 2. Just need to change it like that. Send. And voila, it's working. Without any money, let's say. And a little bit, just a little bit of. So thank you. So let's start with Q&A session. Anyone? Microphone, please.
Small question. What is the response time we saw?
It depends. It depends. If you're running for the first time, you want to see how the response time was, we can look on the Postman, but right now it was pretty much half a second, but if we run it a couple of times, not better. It's a bit quicker.
So it requires warm-up.
Yeah, because I'm not sure if I understand the documentation properly. They are running those AWS Lambda codes in a small containers. And if they are not used, they are some kind of slipped. Okay. Anyone more? Yeah?
I'm trying to register on your website, and there are free plan, but it's only for 1 year, and it's required to provide the information about my credit card.
Yes.
So how does it work?
It exactly rolls as you said. You need to pay money after a year. So I have a free 20.
What happened after a year? It's just blocked, or
no, you're just starting to be charged. That's a business, unfortunately. Okay, more questions? No? Thank you guys. The guys, yeah, okay.
So is there any way to update the code without the browser?
Without the browser? Yes, there is a client tool for this purpose, and it's really easy to use. Just a client tool.
Okay.
I'm not using it, so anyways. Okay, thank you. Anyone? Okay, thank you once again. And the three guys that asked me, please come here, okay? I have some small gift for you. Okay, thank you.